differentiation exercise 1.3. We'll solve some of the remaining examples. Now show that dy by dx is y by x in the following, where a and p are constants. X raised to 7, y raised to 5 is equal to x plus y raised to 12. Now already in previous lecture we saw the generalized case of such problems. Yx raised to m, y raised to n is equal to x plus y raised to m plus n. In such case the derivative is always y by x. So the given expression, taking logs on both the sides, log of the product is sum of the logs. Then using index property, we get 7 log x plus 5 log y is equal to 12 log of x plus y. Now we will differentiate this with respect to x. Derivative of 7 log x plus derivative of 5 log y plus derivative of log of x plus y. Now 7 is constant, derivative of log x is 1 upon x. 5 is constant, derivative of log y is 1 upon y dy by dx, and 12 is constant, derivative of log of x plus y is 1 upon x plus y into derivative of x plus y. So derivative of x plus y is 1 plus dy by dx. Derivative of x is 1, derivative of y is dy by dx. Now multiply this 12 upon x plus y to this bracket and take the term which contains dy by dx to this side. Now take dy by dx common from these two terms and then simplify, taking after cross multiplying 5 times x plus 5 times y minus 12y upon y into x plus y. Similarly 12x minus 7x minus 7y upon x into x plus y. So both the sides having x plus y, so they will cancel to each other, and this simplification comes out to be 5x minus 7y, 5x minus 7y. So they cancel each other, and this red ink x plus y will also cancel to each other, and you get 1 upon y dy by dx is 1 upon x. So dy by dx is y by x. Show that dy by dx is y upon x in the following: x raised to p, y raised to 4 is equal to x plus y raised to p plus 4. Again it is same, only values are different. So values are different. The simplifying and taking differentiate with respect to x. P is constant, so we can take outside, then the derivative of log x. 4 is constant, we can take outside, then we have to find the derivative of log y. Then p plus 4 is constant, we have to find the derivative of log of x plus y. So p by x, 4 by y, dy by dx plus p plus 4 times 1 upon x plus y into 1 plus dy by dx. So again simplify this term and multiply this p plus 4 upon x plus y to this bracket, and then take the term which contains dy by dx to other side. Now take dy by dx common from these two terms. So what you get? 4 by y minus p plus 4 upon x plus y. Now cross multiply these two terms so that the denominator becomes x into x plus y. So and then simplify. So dy by dx is equal to, now numerator is 4x minus py, here is also 4x minus py. So cancel each other, x plus y is also cancelled. So we get dy by dx is y upon x. Sec of x raised to 5 plus y raised to 5 upon x raised to 5 minus y raised to 5 is equal to s square, and we have to show that its derivative is y by x. Now take this sec to this side, we get sec inverse of a square. Then x square plus y square upon x square raised to 5, x raised to 5 plus y raised to 5 upon x raised to 5 minus y raised to 5. Then using componendo and dividendo. What is componendo and dividendo? Suppose a upon b is equal to c upon d, then componendo and dividendo is a minus b upon, no, a plus b upon a minus b is equal to c plus d upon c minus d. This is called componendo and dividendo. Use that here. We get x raised to 5 plus y raised to 5 plus x raised to 5 minus y raised to 5 upon their difference. Similarly, a sec inverse of a square, here denominator is 1, so sec inverse of a square plus 1 upon sec inverse of a square minus 1. And then simplifying this, y raised to 5 y raised to 5 will cancel each other, and x raised to 5 x raised to 5 also cancel to each other, and what we get, 2x raised to 5 upon 2y raised to 5 is equal to p, where p is this constant. So okay, then after differentiating this function, what you get, uh, p is a constant, so d by dx of y raised to 5 is equal to d by dx of x raised to 5. P is constant, so derivative of y raised to 5 is 5 times y raised to 4 dy by dx is equal to 5 times x raised to 4. So simplify this term, we get 1 upon p into 5 x raised to 4 upon 5 y raised to 4. This 5 will cancel each other, and this equation 1 upon p, value of 1 upon p is y raised to 5 upon x raised to 5. We can put here, instead of 1 upon p, y raised to 5 upon x raised to 5. So this cancel each other, and the remaining term is y upon x. Then same example, tan inverse of 3x square minus 4y square upon 3x square plus 4y square is equal to a square. Take tan to that side, we get tan a square. Then using again componendo and dividendo, a plus b, a minus b is equal to c plus d upon c minus d. After simplifying, you get 6x square upon minus 8y square is equal to k, where k is this constant. So what, taking the reciprocal on both the sides, so we get y square upon x square is equal to minus 3 upon 4k. This is our equation number 1. And from this equation, I can write y square is equal to, or 4k y square is equal to minus 3 x square. Now we differentiate this function with respect to x. 4k is a constant, so we can take outside. Then derivative of y square is 2y dy by dx. And minus 3 is constant, so derivative of x square is 2x. So again, these two terms will go to that side, and we get dy by dx is minus 3 by 4k times 2x upon 2y. Here 2 will get cancelled, and minus 3 upon 4k. Its value is y square upon x square. I will put that value in this equation. 1x and this square will cancel each other, and we get y upon x. So this is the derivative of the given function. Now cos inverse of something is equal to tan inverse of a. Again, we will go on the same line. Take cos to that side, cos of tan inverse of a. Let this is a constant, so this constant, say it is a k. So 7x raised to 4 plus y 5y raised to 4 upon 7x raised to 4 minus 5y raised to 4 is equal to k. Using componendo and dividendo, this plus this upon this minus this. That using componendo and dividendo, we get 14x raised to 4 upon 10x y raised to 4 is equal to k plus 1 upon k minus 1. So 5y raised to 4 upon 7x raised to 4 is equal to k minus 1 upon k plus 1. Therefore 5 times k plus 1 y raised to 4 is equal to 7 times k minus 1 x raised to 4. So differentiating with respect to x, we get this 4 will cancel each other, and we get dy by dx is k minus 1 upon k plus 1 into 7x cube upon 5y cube. But k minus 1 upon k plus 1, its value is same, 5y raised to 4 upon 7x raised to 4. So what we get after cancelling these terms, we get y upon x. So this is the derivative of the given function. The next example is log of x raised to 20 minus y raised to 20 upon x raised to 20 plus y raised to 20 is equal to 20. And we have to show that its value is derivative is y by x. So whatever given things, write at that things, then use the derivative the definition of the log. A raised to x is equal to m if and only if log of m to the base a is equal to x. So after using this definition, exponential form, we can write this logarithmic equation in the exponential form. X raised to 20 minus y raised to 20 upon x raised to 20 plus y raised to 20 is equal to e raised to 20. So what you get using componendo and dividendo? Simplify, you get y x raised to 20 upon y raised to 20 is equal to 1 plus e raised to 20 upon 1 minus e raised to 20 is equal to k, say. So taking the reciprocal on both the sides, y raised to 20 upon x raised to 20 is 1 upon k. This is our equation number 1. So from this equation I can get, or I can find the value of y raised to 20. So this is y raised to 20, 1 upon k x raised to 20. So differentiate this with respect to x. So derivative of y raised to 20 is 20 times y raised to 19 dy by dx, and 1 upon k is a constant, so we can keep it as it is. Derivative of x raised to 20 is 20 x raised to 19. So dy by dx is 1 upon k x raised to 19 upon y raised to 19. Therefore dy by dx is y raised to 20 upon x raised to 20. Cancel these terms to each other, we get dy upon x is the derivative of the given function. Now the next example is e raised to x raised to 7 minus y raised to 7 upon x raised to 7 plus y raised to 7 is equal to a. And here we have to show that its derivative is y by x. Again we will use the taking logs on both the sides. So log of e to the base a is x square minus y raised x raised to 7 minus y raised to 7 upon y raised x raised to 7 plus y raised to 7 is equal to k, say. So again using componendo and dividendo. If we not do componendo and dividendo, no problem, but we have to use then quotient rule, okay, for differentiation. It is complicated. So componendo and dividendo is the simplest one. So we get y raised to 7 upon x raised to 7 as k minus 1 minus k upon 1 plus k is equal to 1. I have given this minus 1 to this side, so it becomes 1 minus k. So and taking the reciprocal on both the sides. So y raised to 7 is 1 minus k upon 1 plus k x raised to 7. Differentiate with respect to x. With respect, we get 7 y raised to 6 dy by dx is equal to 1 minus k upon 1 plus k is constant. So derivative of x raised to 7 is 7x raised to 6. So dy by dx is 1 minus k upon 1 plus k x raised to 6 upon y raised to 6. But value of 1 minus k upon 1 plus k is y raised to 7 upon x raised to 7. So after putting that value, the terms will cancel to each other and we get y upon x. Again the same example, here we have to show the derivative of the given function is y by x. On the same line, using componendo and dividendo, find the value of y cube upon x cube. Then find value of y cube and then differentiate with respect to x. So taking the derivatives, 3y square dy by dx is equal to 1 minus k upon 1 plus k 3x square. Now put the value of 1 minus k upon 1 plus k in this expression, that is y cube upon x cube from equation 1. And this y square cancel, x square cancel, and we get y upon x. So this is examples from exercise 1.3. We will continue the same exercise in our next